Hi everyone, my name is Tomer. I work with Josh Baum and Liz Spelke, and what I wanted to present today was work that we're about to do on inference of mass in infants. Mass is really important. Ilker sort of did a good job of setting up this idea of intuitive physics as the basis of common sense reasoning. When we see a scene, we do more than just classify the pixels, right? We see the world in terms of objects that can then actually move and bounce and skip and drag and spill and splatter, and I could go on if I had the time. But a principle, so physics seems to be an important part of common sense reasoning, and mass is, of course, a very basic part of physics, as we know from Newton 1687. It shows up right in F equals ma. And the question is, if it's so important, if it plays all these roles in many different scenes, then we should probably see it early on in infants. And what I mean by see it early on is that they have this sort of underlying representation where they see the mass in one object and then they can transfer it to other scenes, rather than just understanding things as an event, like, oh, I understood collapsing or I understood spilling, but I don't transfer from collapsing to spilling. So how could we test that? Well, we could design many different scenarios and say, okay, if this mass is heavier, depresses stuff more, then we should expect it to move less when it collides with that thing. If it collides less, then it should knock over towers more. If it knocks towers over more, it should pull these things more. If it pulls things more, it should do this. You get the point. Let me show you some of the movies and the movie's not working. It's okay, I factored that in. So let me show you some of the movies that we're thinking of doing now. Okay. Yes? No? Okay, so this other thing that we're thinking of showing infants right now, you can kind of get a sense that the yellow one is heavier than the green one. In this case, you probably get the sense that the yellow one is lighter and that one it's heavier. So imagine you saw that scene and you tried to predict what's going to happen in this other tower knocking over thing. Is it going to knock it over a little bit, a lot a bit? If you saw something being heavy in a collision case, do you expect it to make a small splash or do you expect it to make a big splash? If you saw something making a small splash, do you expect it to then sort of fall down on a piece of rubber and kind of fall down and stop? Or do you expect it to kind of go like that? Right? Each one of these things are very, very different visually, but you have this underlying notion of what a mass is and why it should matter. So what we're actually going to do is we're going to give babies these things, those boxes that you just saw in those videos, and see how much force they enact on these things. And we know how much force they're going to enact on these things because we put in this thing called the Flora Arduino that we can measure the acceleration of these things. This was designed by the Orly Ullman. She did all the hacking for these things. So we know how much force they're going to enact on these boxes based on all the things that they saw. And we're also going to look at how surprised they are between these different videos. And hopefully we can show then some underlying mass representation just to show you that this works. Well, you can't quite see that because it's too bright. But the point is that we've actually tried this and we can see the acceleration and force profiles for some kids.